Hello, myself Minmoy Das, Assistant Professor of W Department of Region Education and Research Foundation, Group of Institution. Today, I will going to discuss the topic of Norton's theorem. This is the subject of basic electrical engineering, which is taughting the all BTech first year students. So, before going to the statement, I will discuss some introduction about the Norton's theorem. This theorem is invented by the Edward Lorry Norton and Hans Ferdinand Mayer, and it is a way to simplify complex circuit by replacing them with a single current source and a resistor. And it is also known as the Mayer theorem. And also goes to the statement, I will discuss the linear, active, and bilateral circuit. So first is the linear circuit. Linear circuit is over the Ohm's law, is called the linear circuit. Active circuit is this circuit presents the active source, means voltage source, current source. This is all of the independent source is present. This is called the active circuit. And bilateral circuit means the property and the characteristics of a circuit does not change with the changing direction of supply voltage or current. Is called the bilateral circuit. So our statement is any linear active bilateral circuit having several number of voltage source and or current source with the resistance can replace with simple equivalent circuit having single current source. This is the Norton's current, and in parallel with a single resistance is the Norton's resistance and a load resistance. This is the Norton's equivalent circuit. So here IN is the Norton's equivalent current, and this current is the is the load terminal, and Rn is the Norton's equivalent resistance, and this it is viewed back into the circuit from load terminal, and IRL is the load resistance. So I load current IL equals to, according to the current division rule, so total current into opposite side resistance which I measured of parallel circuit by total resistance of parallel circuit. So here total current is the IN by into RN by RN plus RL. So this next is the procedure for Norton's equivalent circuit. So first we calculate the Norton's current. So this is the complex circuit because R1, R2, R3, RL, this is a series parallel combination. So then we convert to the Norton's equivalent circuit. First we calculate Norton's current. So when you calculate Norton's current, this load resistance will be removed, and this is the short circuited, and calculate the current across the load resistance. This is called the Norton's current. So Norton's current is the IN equals to V by, because we can have to calculate the total load, total current for this circuit. So there is a R3 and R2 is parallel and R1 is series with this. So total current I equals to V by R2 per R3 plus R1 into opposite, then calculate the IN. So IN is current for this portion. So IN equals to I into I, the value of I is, this is the I value of I, and this IN value, this is the R2, because R2 and R3 parallel, so I value of I into R2 by R2 plus R3. Next is the Norton resistance calculation. So first step for Norton's resistance, if their independent voltage source presence is replaced by their internal resistance as or short circuited as a like a short circuited, and if current source is replaced by their internal resistance as a open circuited, and but dependent source will not be changed. And when you calculate the Norton's equivalent resistance or Norton resistance, and is seen from the load terminal. Open the load terminal and seen from this. So according to this circuit, there is a voltage source is present. So voltage source is short circuited, and calculate the Norton's equivalent resistance. So this portion R2 and R1, R1 and R2 is parallel connection, and R3 is series with this. Next, equivalent circuit. So this is a complex circuit, and there is RL. So IN and RN we calculate previous sides, and RL is known. So calculate the IL equals to IL into IN into RN by RN plus RL. This formula is being from the current division rule of parallel circuit. Next is an example. So this is the circuit, and find the current across 50 ohm resistance using Norton's theorem. So 3 steps: first calculate Norton's current, second step Norton resistance, and last step is the load current calculation. So first step, we remove the load resistance RL and short circuited. So supply current, this is the supply current I. So I is the 12 volt by all resistance combination. There 19 and 100 is series parallel combination, and 500 ohm is the series with this. So getting a value is 0.022 ampere. And Norton's current, this is the Norton's current portion. So according to the, so when we get Norton's total current, then we calculate Norton's current according to the current division rule. So 0.02 into 100, because 100 ohm is the opposite resistance of 90 ohm. So 100 into 100 by 100 plus 90, then the value is the 0.0154 ampere. Next, we calculate the Norton resistance. This portion voltage source, this voltage source is short circuited, and looking from the load terminal. So here 500 and 100 is parallel combination, and 90 is series. Then the value is the 173.33 ohm. And last is the load current. So put the value I. This is our equivalent circuit. So this is the IN, this is the RN, and this is the RL. So load current is the IN into RN by RN plus RL. So outputting this value and get the value is the 0.00895 ampere, and this is the 8.95 milliampere. So we get this Norton's theorem example. We use the virtual lab. So this is the power, this is the source 12 volt, and this is the 500 ohm, and this is the 100 ohm, and this is the 90 ohm resistance, and this is the load is 50 ohm. And this lab, virtual lab, is developed by the IIT Kharagpur. So first case one, first is calculate the load current. So our load current is the actual load current is 0.0089552. So next case, we calculate the determine Norton's circuit equivalent Norton's current or Norton's equivalent short circuit current. So our load side is shorted, and calculate the short circuit current. So value is the 0.001538. Next, our case 2, we calculate Norton's resistance. So this is the this is a voltage source. So this is the short circuited, and this is the we volt here we apply the power or voltage, suppose 110 volt. Then calculate the current and voltage and calculate the Rn, Norton's resistance. So put this, our value is the 173.33. This is the Norton's resistance. And case 3, so we are getting the ISC or IN is the 0.011538 and Rn value and RL 50. So IL is the 0.00895. So this is the ampere. So this is the previously we this is the mathematical calculation calculated mathematically, and next we verify this same circuit in the lab, virtual lab. So then Norton's versus Thevenin's theorem equation. Norton's and Thevenin's are all are the same. Norton's theorem and Thevenin's theorem is the complex circuit to convert to the simple circuit. Norton's theorem is the simple parallel circuit and Thevenin's theorem is the simple series circuit. So in according to the change the circuit by the source transformation. Equivalent circuit by the source transformation. So in Thevenin's circuit there is the VTH and this is the RTH is series, and Norton's circuit IN and RN is parallel. So we apply this Ohm's law, V equals to I into R and I equals to V by R. So here if we change then Norton's Thevenin's theorem to Norton's theorem, so this we put the IN, Norton's current. So Norton's current is the VTH means Thevenin's voltage by RTH, and this current, this resistance is connected to the parallel with the current source, and vice versa is the for Norton's to Thevenin's, this ETH equals to Thevenin's voltage is the Norton's current into Norton's resistance, and this resistance is converted to the connected in series circuit, series with the voltage source. So this is the conversion of Norton's equivalent circuit to Thevenin's equivalent circuit or Thevenin's equivalent circuit to Norton's equivalent circuit. So advantage, the advantage of Norton's theorem. So this is the simplify the complex circuit for easier analysis and useful circuit design and troubleshooting. It is useful and determine the behavior load resistor. Determine helps because if we change the load resistance, then we calculate the load current. And the application, this is a power system. This application which is use a power distribution simple analysis. It is circuit, it is for circuit design, electric circuit design, and load analysis. Because when define change the load, and we calculate the voltage or current from this circuit. So this PPT we discuss the Norton's theorem. Thank you.